Hello friends, welcome to my channel Patra tutorial. In the last video I discussed about the advantages and disadvantages of linked list, right? So in this video I am going to discuss the types of linked list. Okay, so let me start without doing any delay. Basically we can divide the linked list into uh, following four types. Okay, so there are four types of linked lists are there. First one is what? Singly linked list. Second one is doubly linked list. Third one is circular linked list, and fourth one is doubly circular linked list. Okay, so let me discuss one by one. So on the first one is what? Singly linked list. Okay, so let me define this one first. All the nodes in a singly linked list are arranged sequentially by linking with a pointer. Okay, a singly linked list can grow or shrink because it is a dynamic data structure, what I discussed in the last video. Okay, so let me show you one example of singly linked list. Okay, so this is the singly linked list and these are the nodes. Okay, this is second node, this is third node, fourth node and fifth node. See, each node is having two parts, data part and pointer part. So this part will be holding the address of next node, this part will be holding the address of this node, right? And start pointer is always pointing to the first node, that is it will be holding the address of the first node. Okay, and the next part of the last node is always null. Okay, so this is one simple example of singly linked list. Okay, each nodes are connected to each other by this next part or address part. Okay, so this is very simple one, we have already discussed in the previous video, right? And the second one is what? Circular linked list. Okay, see, suppose I want to print right now I am in this node, that last node, and I want to print the first node. So can I go from this node to this node? No, I cannot go, right? Because I don't have any information about the address of this node from this node, right? To avoid this problem we are going for circular linked list. Okay, so let me define the circular linked list first. A circular linked list is one which has no beginning and no end. Okay, a singly linked list can be made a circular linked list by simply storing the address of very first node in the linked field of the last node, that is the next part of the last node. So let me take one example here. Okay, so this is same as this linked list. Okay, but what is the extra thing added here is that the next part of the last node is holding the address of the first node. Okay, suppose this is 200, then 200 will be stored here, so that I can traverse from this node to this node, first node, by using the address of this one. Okay, so this is called circular linked list, but still we have a start pointer which will always points to the address or the which will always points to the first node of the linked list, or it will hold the address of the first node. Okay, this is circular linked list. Okay, and third one is what? Doubly linked list, right? So what is doubly linked list? Every node in the doubly linked list has three fields: previous pointer, next pointer and data part. Okay, so let me show you the diagram first. See this one, this is one doubly linked list and there is one start pointer same as the previous one, but in this case each node is having three parts. See, this is one pointer, this is one pointer field, and this is the data field. Okay, same thing, this is one pointer field, this is one pointer field, and this is the data field. This is one pointer field, this is one pointer field, and this is the data field. But see, the next part of the first node, this one, is holding the address of next node. Okay, suppose this is 200, address is 200, this is 300, and address of this node is 400. Then let me write down here, the next part of first node will be holding what? 300 here, because the address of the next node is 300, and the previous part of this node will be holding the address of the previous node, that is nothing but 200. So 200 will be stored here, and this is what the address of the next node, that is what 400. So 400 will be stored here. And what is the value of this part? The address of the previous node, right? That is nothing but 300. So 300 will be stored here. And what about the this part? Since there is no more nodes available in this linked list, this is the last node, this will be null. And same thing here, since there is no previous node for the first node in the doubly linked list, the previous field of the first node is always null, and start pointer will always hold the address of the first node, that is 200. Okay, so we can access the total linked list by using the start pointer. If we don't have the address of this one, we cannot do anything. Okay, so this is what doubly linked list. Now see what is the advantage. Now we can traverse from last node to first node also, because we have the address of previous node as well. So this was one of the disadvantages of singly linked list, right? Traversal or reverse traversal was difficult, but now in this case we can traverse very easily because we know the address of the previous node also. Okay, and the fourth one is what? Doubly circular linked list. Okay, this is little bit complicated, but still I will try to explain this one in my subsequent lectures. Okay, so a doubly circular linked list is one in which next part of the last node points to the first node and previous part of the first node points to the last node. So let me show you the diagram. Okay, so these are the nodes. Each node is having three fields. First one is previous pointer, then data, then next part. Okay, same thing, previous pointer, data, and next part. This is also previous pointer, data, and next part. Okay, now suppose the address of this node is 100. Okay, let me write 100. This is 200, this is 300. So these are the address of these nodes. Now see, this will be holding the address of the next node, right? And the next node is what? This one. So this will be holding 200 here. Similarly, this part will be holding 100. This will be holding 300, and the previous part of this node is what? 200. Address of the previous node. This is the address of this node, right? Now this is the last node, right? And according to our definition, the next part of the last node points to the first node. That means the next part of the last node will be holding the address of the first node, and the address of the first node is what? 100. So this part will be holding here 100, and the previous part of the first node, this one, right? This is the first node and previous part is this one, and the previous part of the first node points to the last node, right? That means what? The previous part of the first node will be holding the address of the last node, and what is the address of the last node? 300. So 300 will be stored here. Okay, and what is the advantage of this one? I will be discussing in detail in the next video. So first let me discuss these three linked list: singly linked list, circular linked list, and doubly linked list. Then I will go for doubly circular linked list. Okay, and next is what are the operations we can perform on a linked list. Okay, so these are the very simple or primitive operations we will be performing in the subsequent videos on the linked list. Okay, so first one is what? Creation. First we need to create one linked list. Okay, suppose I will ask you to create a linked list to store 5 integer value. Okay, so you need to create the linked list and store those integer values, whatever I'll be giving you. Okay, and insertion. Suppose there is already one linked list is there like this, and I will ask you to insert a new node at the beginning of the linked list. That means what? At this position you need to insert a new node, right? So how to create or how to allocate the memory, and how to insert it, and how to update the start pointer. Previously start pointer will be pointing to this node, right? But after inserting this node, this will be the first node, so start will be pointing to this node, and this will be pointing to this node. Okay, so this is insertion. Similarly we can insert a new element here in the middle of the linked list or at the end of the linked list. Okay, so all these things we'll be discussing one by one in the subsequent videos. Okay, so let me erase this part. Okay, the next one is what? Deletion. Okay, suppose this is my linked list. Okay, start pointer is there. Now I will ask you to delete this node, or this node. If you delete this node, what you have to do? You need to update the start pointer. That means start pointer will be pointing to the this node, because after deleting this node, this will be the first node, right? Same thing, if I ask you to delete this one, then you need to update this part, so this will be pointing to this node. Okay, so how to delete from different positions in a linked list, like start or beginning of the linked list, end of the linked list, or in between the two nodes. Okay, all these things we'll discuss one by one. Traversing means what? Printing all the nodes or all the data elements of every node in the linked list once. Okay, so how to traverse the total linked list, all those things we'll be discussing. And searching means what? Whether you need to find whether a particular element is present in the linked list or not. One linked list will be given like array or whatever, means one linked list will be given to you of size 10, 20, 30, or it can be 100, 200, something like that, and one searching element will be given. Okay, and you need to find whether that searching element is present in that linked list or not. Okay, so how to perform all these operations we'll be discussing one by one in the subsequent videos. Okay, so thanks for watching, and if you have understood something from this video, if you are happy with my teaching, then please like, comment, and subscribe to my channel. And thanks for watching. Thank you for your support. Bye bye.